Hey everyone, welcome back to my channel. I hope you are not doing awesome. So this is the follow-up video on the previous video. So in the previous video we covered your Java memory management. So in this video it's Java versus C Sharp garbage collection. Okay. So yeah, same way like in the last video, I drafted one article. So here also I have one article, and we'll start with that. Okay. So here, Java versus C Sharp garbage, but make sure you have watched the previous video. That is a prerequisite for this video. Okay. So Java versus C Sharp garbage collection, a developer's guide to memory management. Cool. Okay. So understanding garbage collection, Java versus C Sharp. Yeah, I drafted this today. Okay. So you can ignore this. Just give me a sec. Okay. So memory management is one of the most critical aspect of application performance, yet it's often misunderstood by developers. If you ever wondered about the differences between Java and C Sharp garbage collection, or which one might be better suited for your next project, you are in the right place. Okay. Both Java and C Sharp handle memory management automatically through garbage collection. Yeah, which is absolutely correct. Like in C or C++, here you do not need to worry about that. It's automatically happen. Okay. But they take notability. They take notably different approaches. Okay. But but they take notably different approaches. Let's dive deep into these differences and explore what they mean for your applications. Cool. So, what is garbage collection? So, before we compare the two, let's establish what garbage collection actually does. So, as we already know, like garbage collection, okay, let's read what we have written here. Garbage collection is an automatic memory management process that identifies unused objects in your application memory, frees up memory occupied by these unreachable objects, prevents memory leaks that could crash your application. पता नहीं ये क्यों अच्छा लगता है memory leaks. सकते बहुत बड़ी चीज़ है. Reduces developer burden by handling memory cleanup automatically. Think of it as an automatic generator for your application memory, constantly cleaning up after your code so you don't have to manually manage every allocation and deallocation. Absolutely correct. Like in C Sharp and Java, you do not need to worry about it's automatically happen. Like in your Java, it is handled by your JVM. In C Sharp, it's done by your CLR, Common Language Runtime. So let's see. Key differences between Java GC and C Sharp GC. I know a bit about C Sharp GC, but ज़्यादा कुछ नहीं पता था. बट ये आर्टिकल ड्राफ्ट किया तो मुझे भी ज़्यादा कुछ पता चला. सो आई एम जस्ट शेयरिंग दिस विद यू ऑल. So runtime environment, Java GC runs inside JVM and C Sharp GC runs inside CLR, which is part of .NET Runtime. Cool. Both work on the same principle, heap-based memory, automatic cleanup of unreachable objects, but the runtime implementations differ significantly. The JVM has been around longer and has had more time to mature and optimize its garbage collection strategies. Okay. And if we talk about your generational model and collection algorithm, so Java GC, as we already know, it's use your we have GC collector options like your serial, parallel, GC1, which is default in now year after Java 9, and GC1, GCN, Shenandoah, etc. Like default Java 9 plus is J1, garbage first GC, region based and low pauses. Modern options like VGC and Shenandoah aim for near pauseless collection. Heap divided into Eden, Survivor, and AllGen. This was about your Java. You can choose the right collector for your specific use case. So these all we already like covered in the previous video. So now comes to your C Sharp. Always generational with 3 generations. So like here we have only 2 generations, like your young generation and the old generation, and there we have inside Java, I would say we have young, old, and we had our string pool, which was also the part of that heap, and then Metaspace. But here we have only 3 generations: Gen 0, Gen 1, Gen 2. Short-lived objects collected most frequently. Survivors from Gen 0, intermediate collection. Long-lived objects collected least frequently. So you can relate these with our Java generations we have inside Java. I don't think so. I need to like draw and explain these all. This is more or similar, but here we have only generation. So like the very first will go to your this and the long level here, and those are your survivors. Okay. Since .NET 4.0, it includes background GC similar to concurrent collectors in Java. Okay. Like we have GCC, which is your concurrent collector, and it's a background GC in .NET 4.0. No multiple pluggable GCs like Java. The GC is unified across runtimes. Simpler model but less flexibility for specialized workloads. Real world impact. Java's variety of collectors means you can optimize for throughput, parallel GC, low latency for your GCC, or backend performance using G1. C Sharp's unified approach means less configuration but potentially less optimization for edge cases. Here your Java wins. But we cannot say like Java wins or C Sharp not. I'll see like there are a couple of factors, and I believe it totally depends on the requirement or the use case. Next we have manual control and APIs. So inside Java we have very limited direct control. System.gc only request GC, JVM can ignore it. Yeah, you don't know, like it doesn't ensure that it will immediately run the GC. It will run when your JVM decide, yeah, this is the right time, and it will done. No way to explicitly free memory philosophy. Trust the JVM to know best. This is for your Java. And what is inside C Sharp? Provides more APIs for developers. GC.collect forces garbage collection, still discouraged but available. And then we have GC.get total memory. There we had like runtime we used in Java. Here we have total memory, checks memory uses. GC.add memory pressure. GC.remove memory pressure. Tell the GC about unmanaged resource uses. I believe निखिल को आना था अभी. No, this was company. Okay. So GC dot add memory pressure and GC dot remove memory pressure. Tell the GC about unmanaged resource usage. Okay, we can explore these as well in C Sharp. Also provides iDisposable and using blocks for explicit deterministic cleanup of unmanaged resources like your files, sockets, DB connection. Yes. So like have you observed if you are working with C Sharp, so you always use for your sockets and DB connection files, we use using block, using then your round braces, we open our connection, and this is scope based with your curly parenthesis. When your curly parenthesis ends, the scope is ended, and it automatically cleans up the memory. Okay, that is your using and iDisposable blocks for deterministic cleanup. Okay, philosophy: give developers the tools they need, but educate them on best practices. Interesting. Next, we have resource management patterns. So Java had finalized, deprecated since Java 9 removed in Java 8. Yeah. And now encourages try with resource autoclose for deterministic cleanup. Yeah, because now we are using, as you can see their example, we have try, we are opening the file stream. This will automatically close here using your autoclosable. This is scope based. Earlier we had finalized to do this, but in Java 18 it is removed. I can say the deprecated. Uses the dispose pattern. Inside C sharp, we use the dispose pattern using your idisposable, and using idisposable is an interface. You can learn that. Finalizer class name. This is as similar to your finalize exists but discouraged replaced with idisposable. As you can see the example. We are opening this file stream. We use the file automatically disposed here. If you see, there is no such difference in the syntax wise, in the resource management pattern wise, but yeah, and Java has like more algorithms and your collectors type to do these things. Both patterns achieve similar results, but C sharp's approach is more integrated into the language and runtime. Hmm. Handling unmanaged resources. Yeah. So Java most resources are wrapped in the JVM. Unmanaged resources like a file handle sockets are released using try with resources. Hmm. As we saw here. JNI Java native interface requires careful manual management. Okay. But if we talk about C sharp, has tighter integration with unmanaged window resources. Idisposable and safe handle patterns are common for wrapping unmanaged resources. P slash invoke and com interop scenarios are well supported. Better tooling for mixed managed unmanaged scenarios. Tuning, and the next we have our tuning and configurability. So for Java, it's highly tunable via JVM Flex. As I showed you yesterday, we have some bash commands that you in and on the terminal, and you can just tune with your flex. Multiple collectors for different workloads like low latency, large heaps, throughput. You can play with that. Advanced GCs like ZGC can handle heaps of terabytes with less than 10 ms post times. Yeah. ZGC. Extensive documentation and tooling for GC analysis. Yeah, here Java wins. Less tunable, mostly automatic and adaptive. Some knobs like workstation versus server GC. And you have to enable this inside your config, like the JC server or the workstation you need. Can switch between concurrent background GC or non-concurrent. Yeah, it can switch between your concurrent and non-concurrent. Generally, the CLR hides GC complexity for developers. The focus on just the focus on it just works rather than extensive tuning. So like it's hide the complexity for developers. So like developers can primarily keep their focus on developing the business like application, or might be primarily focused on the business logic. But this things also should be in the hand of developers. But I believe this Java is providing performance in different scenarios. Low latency applications. Java supports ultra low latency GCs like ZGC and Shenandoah, widely used in high frequency trading and real time systems. Yeah, Java is winning here. GC has improved dramatically in .NET Core, .NET 6 Plus, but traditionally not as tuned for ultra low latency scenarios. This is improving, but like not tuned for ultra low latency scenarios. Just wait. Then we have large scale applications. Java. Mature tooling and collector design for massive heaps, like a multi terabyte. Hmm. Like your mature tooling and collectors design for massive heaps, multi TB. Excellent for enterprise applications, particularly strong in Windows Server environments. This is more closely this is more closely to your Windows Server. No, you can like configure with the Linux server as well. Okay. So memory constrained environments can be configured for minimal memory usage with appropriate collector selection. Yeah. In Java, inside Java, you have a choice. You can select the appropriate collector, like which GC collector you want to use and minimal memory uses. But inside your C Sharp, generally more memory efficient out of the box for typical business application. This is more memory efficient out of the box for typical business applications. Yeah, that's why inside your banking and wealth management sites, now C Sharp is evolving more and more. Now here is the detailed comparison table. So you can go with this, I believe. Feature, default, collector, this, generational, three gens. Oh, yeah, we have three generations. High, limited, workstation versus server, and we have to configure this inside our config file. High, flex, multiple algorithms, cool. APIs for control, limited, only system.gc. Here we can use gc.collect and idisposable. Unmanaged resource management, like try with resources plus autoflow 7. Idisposable using safe handle. Finalize, same these, I don't think so. Advanced collectors, here we have this, here we have only GC, generational plus background. This is automatic. You do not need to worry about this. Then we have low latency suitability. Excellent, good in .NET Core, not as customizable. Yeah, you cannot. Because this is also tuned for your ultra low latency, but .NET C# was not. Learning curve steep for optimization, gentle, mostly automatic. Tooling extensive, JVisual VM, GCEZ, integrated pref view, memory. Just go and check it out, these tools. Okay. Then when to choose which, choose Java GC when ultra low latency is critical. But I believe C Sharp is also, people are using C Sharp where they are just the low latency, like the trading system or the real time applications. I saw somewhere they are using Signal R for the real time, and that was also the trading platform. Then you need fine grained control over memory management, and here building typical enterprise applications. I think you can just read these are the like self-explanatory when to choose which. These are self-explanatory. In future trends, work platforms continue to evolve. Java is pushing the boundaries to Java is pushing the boundaries of low latency computing with Project Loom, virtual threads, and continued improvements to C, JC, and Shenandoah. C Sharp is focusing on cross-platform performance with .NET 6 Plus and improving startup times and memory efficiency, especially for cloud and microservices scenarios. And then if we conclude, I think that depends on the scenario. This is tunable for given the controls specialized workloads. It's therefore choice of application where you need to squeeze every millisecond of performance or handle massive scale. Simpler to use, offer more API or developers, integrate strongly with the deterministic cleanup via idisposable. It's perfect for most business applications where developer productivity and maintainability matter more than ultimate performance tuning. यहाँ पे आगे लगता है कि छोड़ दो, फिर मत जाओ C sharp की साइड. Neither approach is inherently neither approach neither approach is inherently superior. They reflect different philosophies about how much control developers should have over memory management. The best choice depends on your specific requirements, team expertise, and performance needs. Yes, because it totally depends on the what is your project requirement, what are the needs, in which team expertise you have. So these all depends on your like the requirements. What matters most is understanding these differences so you can make informed decisions and write better code regardless of which platform you chose. Okay. Have questions about garbage collection in your specific use case? The key is to profile your application, understand your performance requirements, and choose the approach that best fits for your team's expertise and project needs. I'm getting again call. हेलो.
तेरे आसपास कोई लैक में मल्टी क्लिनिक है क्या?
तू आ गया क्या?
नहीं।
So, yeah, that's all for this video. If you found this video helpful or useful, so don't forget to like, subscribe, or share. I'll see you in the next video. Till then, keep learning, keep growing. Bye bye.